All right, we're going to walk through 4 of the practice problems that I gave you, and then you will complete 3 of them on your own. The first one we're going to do was from page 404, guided practice number 1, and this one is more of a word problem. So the wall-mounted mirror shown uses parallelograms that change shape as the arm is extended. In parallelogram JKLM, suppose the measure of J equals 47, and then find each measure. So one of the things that I want to encourage you to do when you have word problem type situations is sometimes it's easier to redraw that parallelogram and label it. It can be, this one is a little bit easier to see, but that's not always the case. So if I just take a minute to redraw the parallelogram, and mine may not be perfect, but that's okay. So you redraw the parallelogram, and then you're going to label it with the information. So this was angle J, and over here was K, down here was L, and to the left was M. And I'm told that the measure of J is 47, so I'm just going to write in 47 there, because that was in the given information here. The measure of J is 47. So first was to draw the parallelogram and label it. And then step 2, I'm going to solve using those various properties of parallelograms that we just went over in the previous video. So part A is to find the measure of angle L. Okay, this is angle L right here. And what we know from our properties of parallelograms is that opposite angles are congruent. So that means that angle J is congruent to angle L. And if those two angles are congruent, then the measure of L must be the same as J, so it will be 47. And I want you to write these types of things down as you're working these out. Write out things like angle J is congruent to angle L. That helps you know why you were able to solve it that way, so you don't forget when you look back at your notes. Second, you're asked the measure of angle M. What's that? Well, we also know from our properties that consecutive angles in a parallelogram are supplementary. They equal 180. Well, I just determined that L is 47. So that means L plus M must equal 180. So I can say the measure of angle M plus 4, or I'll just put the measure of angle L at first, equals 180. Well, I know that this is 47 for measure of L. So the measure of angle M plus 47 equals 180. And I want you to write all of these steps out in your notes. I want you practicing writing all the steps out. And then 180 minus 47 gives me the measure of angle M. And so the measure of angle M, and you can do that on your calculator, is 133. 133. Okay. And then finally, question C. Suppose the arm was extended further so that the measure of J is 90. Okay, so let me erase. Let's see, let's change this. And J is now going to be 90. Okay, so I can notate that by just making a right angle mark. I don't need to, I can write in the 90 if I want, but I can just make the right angle mark. Well, we learned from theorem 6.6 that if one angle in a parallelogram is a right angle, then all angles are parallelograms. So C would be all other angles would measure 90, and the reason is if one angle in a parallelogram equals 90, then all angles equal 90. Okay? So if one angle is right or equals 90, then all angles are right or equal 90. And that is your reasoning. Next, number 2, find the value of each variable in each parallelogram. Those are the instructions for 2, 3, 4, and 5. And I'm going to be doing 2 and 4 for you. 2 and 4. So we'll start with 2. And so the variable that we need to be looking at is right here at angle L. We need to just solve for x. Okay. So again, from our properties, we know that angle J is congruent to angle L, which means their measures are the same. So 75 equals 2x minus 1. So that's just substitution. Okay? And then I'm going to add 1 to both sides, so I get 76 equals 2x. And now I'll divide both sides by 2 to get x by itself. Divide both sides by 2. So x is going to be 38. And again, I want you writing all these steps out. On your assignment, when you show it to me, all of the steps need to be written. And I want you to do that for each problem so that you get practice and making sure that you fully understand what you're doing here, not just writing in answers. Writing in answers will not get you credit for this assignment. You must show work. Okay, number 4, which is the third problem we're doing. Again, find the value of each variable in the problem. Well, now I have 2 variables that I'm trying to find. I need to find A, and I'm also going to need to find B. So I'll start with A. Well, based on the properties of parallelograms, what I know is that the diagonals bisect each other. So that means this line, this segment is congruent to this segment, and this segment is congruent to this segment. So I want you to do that. I want you to draw on your paper, draw the parallelogram, draw the markings, draw all of that so that you know what you're referring to. Okay, and if you need to pause the video to do that, that's fine. So because they're congruent, we know that 2 equals A minus 7. So I just add 7 to both sides, so A equals 9. And then next, I need to find B. Well, I can see that B, this segment here, sorry, not B, but this segment is going to equal 10. So 2B minus 6 is going to equal 10. So 2B minus 6 equals 10. So I'll add 6 to both sides. 2B equals 16. And then I just need to divide both sides by 2. And B equals 8. And I have solved for both variables. So we're using those property of parallelograms to solve various problems. Okay, again, I want you to show all of your work. And finally, we're going to be doing a proof. We're doing number 7. It said write the indicated type of proof for the instructions, and it told you to do a paragraph proof. You know, doing 2-column proofs right now is fine. If you want to do a paragraph, that's fine. I'm going to show a 2-column, and as you work through problems, unless I specify and tell you, yeah, for sure, do a paragraph proof, doing 2-column is fine. So we're given that parallelogram ABCD. In that parallelogram, angle A is a right angle, and we need to prove that angles B, C, and D are also right angles, which was theorem 6.6. If one angle is a right angle, then all 4 have to be right angles. So we can't use that theorem because we're trying to prove that theorem. So we're going to have to use other theorems that we know to prove it. So remember, we set up our columns, and we're going to start with our statement side. So one is that, let's see, parallelogram ABCD. I am going to abbreviate right now just because I'm typing. In that, angle A is right. Okay, so you may write it out with the symbols. I just can't do that when I'm typing, so I just did it that way instead. And the reason is given. Okay, next. For 2, we know that, and here, I'll write these ones in now. Hopefully it'll be legible. Statement 2 is that the measure of angle A plus the measure of angle C equals 180. Okay, so I'm saying A and C are supplementary, and I know that from one of my theorems that I just learned. That was theorem 5, that consecutive angles in a parallelogram are supplementary. And so I'm just going to write that. Consecutive angles in a parallelogram are supplementary. So that says consecutive angles in a parallelogram are supplementary. That is the abbreviated version, sorry, it's a little hard to read. So I know that those equal 180, and I know that a measure of A is 90. So I can say, because it's right, 90 plus the measure of angle C equals 180. So what did I do? I substituted 90 in for A. So that is substitution. Okay, next, I can solve for angle C. If I subtract 90 from both sides, I get the measure of angle C is 180. So what I was doing to get that is subtraction property. Okay, so that is the subtraction, not substitution, but subtraction property. So, whoops, I'm sorry, not 180. Whoops, that was a mistake. That should be 90. It was a 180 minus 90, sorry. Little boo-boo there. Measure of angle C is 90. So I'm going to go ahead and mark that on the drawing. This is 90. So I now know 2 of them, and I'm supposed to prove 4 of them. Well, what I also know from previous theorems is that angle A and angle D are congruent because opposite angles in a parallelogram are congruent. Okay, I learned that as well in my theorems and properties of parallelograms. So I can say the measure of D is 90, and that is because opposite angles in a parallelogram are congruent. And then, so that one is now a right angle. And then I also know that C, for that same property, is congruent to B. And so I can finally say the measure of angle B equals 90 because opposite angles in parallelograms are congruent. And that is my proof. You have 3 more problems to do on your own and enter the Google form link. So please make sure you do that when you are done.